Right now, at this very moment, there could be a massive planet lurking in the darkness of our solar system, hurtling toward Earth on a collision course that would end all life as we know it. At least, that's what millions of people believe. They call it Planet X, or Nibiru, and according to doomsday theorists, it's been hidden from us by governments and scientists who don't want us to know the truth. But here's the thing. The laws of physics don't care about conspiracy theories. They don't care about what we believe or what makes a good story. And when we actually apply the mathematics of orbital mechanics to this supposed rogue planet, something fascinating happens. The entire theory collapses under the weight of its own impossibility. I'm going to show you exactly why, using nothing but the same principles that guide every satellite, every spacecraft, and every celestial body in our universe. Let's start with what Planet X believers actually claim. According to the theory, there's a massive planet, sometimes described as being several times the size of Earth, that has an extremely elliptical orbit. This orbit supposedly brings it into the inner solar system every few thousand years, causing catastrophic events on Earth. Some versions claim it's on a 3,600-year cycle. Others say it's already here, hiding behind the sun. The dates for its arrival have been predicted and revised countless times. First it was supposed to arrive in 2003, then 2012, then 2017, and the goalposts keep moving. But let's put aside the failed predictions for a moment and examine something more fundamental. Could such a planet even exist in the orbit they describe? Here's where orbital mechanics comes in. Every object in space that orbits another object follows specific mathematical rules discovered by Johannes Kepler in the early 1600s and later explained by Isaac Newton through his law of universal gravitation. These aren't suggestions or approximations. They're laws that govern everything from the moon orbiting Earth to galaxies rotating around their centers. Kepler's first law tells us that all orbits are ellipses, not circles, with the sun at one focus. That's fine. The Planet X theory could accommodate that. But Kepler's second law is where things get interesting. It states that a planet sweeps out equal areas in equal times. What this means is that when a planet is closer to the sun, it moves faster. When it's farther away, it moves slower. This is why comets seem to speed up as they approach the sun and slow down as they head back out into space. Now let's apply this to the supposed orbit of Planet X. If this planet has the extremely elongated orbit described in the theory, spending most of its time in the outer solar system and only briefly passing through the inner solar system, we can calculate how fast it would need to be moving at different points in its orbit. And here's the first major problem. When Planet X would be out in the distant reaches of the solar system, beyond Neptune or even in the Oort cloud, it would be moving incredibly slowly. We're talking about a crawl through space. At those distances, the sun's gravitational influence is extremely weak. For an object to maintain an orbit that brings it all the way back to the inner solar system in a reasonable time frame, the mathematics simply doesn't work with the timescales claimed by the theory. Let me put this in perspective. Neptune, the outermost major planet, takes 165 Earth years to complete one orbit. It's about 30 times farther from the sun than Earth is. If Planet X were to have an orbit that took it, say, 10 times farther than Neptune, we're not talking about a 3,600-year orbit. We're talking about timescales that would be dramatically longer, based on Kepler's third law. This law states that the square of the orbital period is proportional to the cube of the semi-major axis of the orbit. In simpler terms, the farther out you go, the orbital period increases exponentially, not linearly. A planet at the distance described in most Planet X theories would take tens of thousands, or even hundreds of thousands of years to complete a single orbit, not the few thousand years claimed. But let's say we ignore that problem for a moment. Let's assume somehow this planet does have the orbit they claim. The next issue is gravitational influence. A planet several times the mass of Earth moving through our solar system would have massive gravitational effects on everything around it. It would perturb the orbits of the known planets. We have extraordinarily precise measurements of the orbits of all the planets in our solar system. We can predict where Mars will be 100 years from now down to the meter. If a massive rogue planet were swinging through the inner solar system every few thousand years, the gravitational tugs on the other planets would show up in our observations. We would see unexplained variations in their orbits. We would see asteroids being flung out of their regular paths. We see none of this. The orbits of our planets are exactly where Newtonian mechanics says they should be. There's also the issue of detection. Modern astronomy isn't done by a handful of scientists peering through telescopes anymore. We have automated sky surveys that photograph the entire visible sky repeatedly, looking for anything that moves or changes. Amateur astronomers with backyard telescopes are discovering asteroids and comets regularly. The idea that a planet-sized object could be approaching the inner solar system and remain hidden is absurd. Space is big, yes, but a planet reflects sunlight. It would be visible. Professional and amateur astronomers across the entire planet, in different countries with different governments and different agendas, would have seen it by now. The notion that they're all part of some massive conspiracy requires us to believe that tens of thousands of independent observers are all keeping the same secret. That's not how science works, and it's not how human nature works. Let's talk about what would actually happen if a massive planet did approach Earth. The gravitational effects would be catastrophic, but not in the way doomsday theorists describe. They often talk about Planet X causing earthquakes, volcanic eruptions, and tidal waves. But the real danger would be to Earth's orbit itself. A close pass by a massive object could alter our orbital path around the Sun. This could change our distance from the Sun, which would have devastating effects on our climate. It could increase the eccentricity of our orbit, leading to extreme seasonal variations. In a worst-case scenario, it could even eject Earth from the solar system entirely, or send us plunging into the Sun. These aren't exaggerations. The mathematics of gravitational interactions shows us that planetary orbits are more fragile than people realize. The fact that Earth has maintained a stable, nearly circular orbit for billions of years is evidence that no massive rogue planet has been swinging through our neighborhood. There's another aspect worth considering. Where did this supposed planet come from? Planets form from the protoplanetary disk that surrounds a young star. Our solar system formed about 4.5 billion years ago from such a disk. All the planets formed in roughly the same plane, which is why the solar system looks relatively flat when viewed from the side. A planet on a highly elliptical orbit that takes it far above or below this plane would need a very special explanation. Did it form there? Unlikely, because there wouldn't have been enough material in the protoplanetary disk that far out. Was it captured from another star system? Possible, but capturing a rogue planet into a stable orbit is extraordinarily difficult and would require a very specific set of circumstances. And if it happened, we would expect to see evidence of the gravitational chaos it caused when it was captured. Some believers point to ancient civilizations and their astronomical knowledge as evidence for Planet X. They claim the Sumerians knew about this planet and called it Nibiru. But this is a misinterpretation of ancient texts. The word Nibiru appears in Babylonian astronomy, but it referred to different celestial bodies at different times, usually Jupiter. There's no ancient text that describes a rogue planet on a collision course with Earth. These interpretations come from modern writers, not from actual scholars of ancient languages and civilizations. We need to be very careful about projecting modern ideas backward onto ancient cultures and then using those projections as evidence for modern claims. So why does the Planet X theory persist despite all this evidence against it? Part of it is human psychology. We're pattern-seeking creatures. We see connections even where none exist. We're also drawn to stories that make the world seem more dramatic and meaningful than it might otherwise appear. The idea that scientists and governments are hiding a terrible truth is, in a strange way, more comforting than the reality that the universe is largely indifferent to us. It gives people a sense that there's a hidden order, even if that order is sinister. But the real universe, the one revealed by mathematics and observation, is far more interesting than any conspiracy theory. The actual dynamics of planetary motion, the delicate gravitational ballet that keeps our solar system stable, the fact that we can predict celestial events thousands of years in advance using equations that fit on a single page, these are genuinely awe-inspiring. The truth is, there are real objects in the outer solar system we're still discovering. The search for a possible ninth planet, not Planet X, but a legitimate hypothesis based on the clustering of certain Kuiper Belt objects, is ongoing. This hypothetical planet would be far beyond Neptune, in a distant orbit that would take tens of thousands of years to complete. It wouldn't come anywhere near Earth. It wouldn't cause catastrophes. But if it exists, and that's still a big if, it would be a fascinating discovery that would tell us more about how our solar system formed and evolved. That's real science. That's exciting. And it doesn't require us to abandon the laws of physics. Mathematics doesn't lie. Orbital mechanics works the same way everywhere in the universe. The same equations that describe how the International Space Station orbits Earth also describe how planets orbit the Sun. We've tested these principles over and over again. We use them to navigate spacecraft across billions of miles with incredible precision. When we apply these well-established principles to the Planet X hypothesis, the theory falls apart completely. The orbit described is impossible given the timescales claimed. The lack of gravitational perturbations on known planets contradicts the existence of such a massive object nearby. The failure to detect it despite our comprehensive sky surveys makes the conspiracy required to hide it absurdly elaborate. Planet X, Nibiru, whatever you want to call it, is mathematically impossible. And sometimes the truth really is simpler than the fiction.